Kinematics, lesson number 2. We will be discussing the idea of reference frame today. Actually, at intermediate level, people think that discussion of a reference frame is not required. We can just do the problems taking some formulas and all that. But remember, whether somebody likes it or not, whether somebody knows it or not, when somebody is aware of it or not, a person working out a problem is not just working it out on a paper and a blackboard, but he is working or she is working it out in some or the other reference frame. You keep hearing words that motion and rest are relative terms, isn't it? Did anyone see this kind of a statement? Motion and rest are relative terms is one sentence, one statement we keep hearing in the textbooks, from the textbooks. What it means is they don't have a unique absolute meaning. They have a meaning with respect to the surroundings in which you watch the motion of a body, or which you watch the body, or it depends upon the viewpoint from where you study the motion or the rest. When you are sitting now in the room and listening to this lesson, you look at somebody who is sitting by the other side, by your side, and that's somewhere at some distance from you, you say that person is at rest. But somebody watching from moon, for example, both of you along with the earth are in motion. Why all that? You can think of a simple say a box car. I use the word all the time, box car, like this. If two persons are standing or sitting here facing each other, this A and B say that the other fellow is at rest. A says B is at rest, B says A is at rest. But somebody watching from here will say that both are in motion if the bus is moving like that. So definitely, motion and rest are relative terms only. They have a meaning with respect to the point from where you watch a body and try to understand its motion or non-motion. So we have to make it more systematic by using the word reference frame. We'll say that these two persons, A and B, are in motion in a reference frame fixed to the ground, but B is at rest in a reference frame fixed to the bus. Do you understand my words? Both A and B are in motion in a reference frame fixed to the ground. B is at rest in a reference frame fixed to the bus. Did you hear my statements properly? Hello. In fact, I'll provide you another interesting example which keeps coming up in exam questions very frequently. Say there is some boxcar going like this. We can say with a constant velocity. V is constant. Now, there's a person standing here, okay, and throws a ball up. Okay. Now, we told that this boxcar or the bus is moving with a constant velocity. He throws the ball up like that. First, my question is whether he'll catch the ball, whether the ball will come back to his hands. And second thing, how does this fellow look at the motion of the ball, and if I put one more person on the ground, how does he say or she say the ball is behaving?
So
Can somebody
the
answer my question?
person who is throwing the ball will be like just went up and came back into his hand.
It will go and come back to his hands. First of all, are you sure about it?
Yes, sir.
Okay.
And
So
the person who is outside, person B, for him it would be that the ball is moving front and then coming back into his hand.
tell me, ball is moving?
Like in the direction which the car is moving, the ball is moving in the same direction and then coming into his hand.
The second statement is not good. So for
Like
A,
parabolic path, sir.
parabolic path. So it goes up and comes back to him. Like if he's writing the equation, he'll simply say it's going up by the equations of motion. He will write which way? S equals ut minus half
Plus half.
It goes only in one direction, then comes back like that. That's correct. And Amar says for this person B, it follows a parabolic path, he says. But will he catch the ball? The person A, Amar?
Yes, sir.
So how do you understand that? Even the person will be moving like this for him. The ball follows a parabolic path and then he catches it. Isn't it?
Yes, sir.
So
Yes,
this
sir.
is what the person B says. Isn't it so? Others, please respond.
Yes.
Yes, sir.
So the path, can you explain it, Amar? Like why is it following a parabolic path and all that?
Sir, the ball
Give
is
the right answer, but can you explain
moving.
it?
Yes, sir. Yes, sir.
Tell me.
Sir, the person on the ground is in red, sir, but the bus is moving with some velocity. The ball in the bus also moving with some velocity.
So that's correct. What he says is this person was holding the ball, and the person is standing in the bus. So whatever velocity is there for the bus will be there for the person and will be there for the ball also with respect to him. So this velocity and this velocity makes the ball go this way. That's what he's saying, isn't it so?
Yes, yes.
But how about him actually? For him, he is moving with same velocity of the bus and ball also is moving with the same velocity of the bus. So for him, this will be at rest in this direction. There's no velocity for the ball in this direction for him. Do you follow?
Yes, sir.
So that's why you'll say the motion is a straight line motion when you watch from the bus, and this motion is a parabolic motion when you watch from outside. So which is correct? Which is the actual one, Amar? Both are correct, right? Both are correct.
Reference frame.
So that's correct. So that's why we know we require to discuss what we call as reference frame. Since motion and rest are relative terms, we need to discuss first of all what's the reference frame. Okay, like this you can give many examples. Let me give one more example, very interesting, because these things slowly you will convert into equations, mathematics only, just not talking dry words. Let me say one bird, say an eagle.
Sir, like I have a doubt, sir.
Ah.
Sir, like what if the bus or car which is moving does not have a roof, and I try to throw an object far too high? Then it will not come now.
What did you say?
The bus do not have a roof.
Okay.
Then I have thrown an object. It will not come to my hand again, Nasir.
Why not?
Since
But
I
it
am
depends
moving
on the
again.
angle.
It
Yes.
doesn't have a roof, doesn't matter.
Like I'll throw it higher, sir.
Huh?
I'll throw it
However
above.
high you throw it, no problem, because of course you need to consider air there, but supposing air resistance is not good enough, look, you throw it so high, doesn't matter.
Yes,
Huh?
yes.
It will still have this velocity in the forward direction. Okay. So you move, the ball moves. Vishnu.
Yes, sir. Yes, sir.
Do you follow?
Yes, sir.
Right. Yeah, another example I was providing. Say this eagle has some insect or worm in its beak. It's going with some velocity v like this. It drops this insect. Okay, how does the insect see the worm to be falling, or how does a person from the ground see that worm to be falling?
So the eagle will see it as the worm is following it, but it is going down. But for the person, it would be like a parabolic motion to the ground, as there is velocity.
So that's correct, isn't it? How about others? No, this is what you mean, the intuitive feeling. That should be there. Slowly, we need to convert that into equations. Do you follow?
Yes, sir.
Same is the case when a bomber plane I'll give many examples. So, very well. You understood the whole thing, the previous one, whatever Takshil was saying?
Yes, sir.
Yes, sir.
The eagle says it's simply falling like that. But you should know why. It's similar to what we talked. But for him, it follows like this, isn't it? For him, this is a velocity v for the thing. He is at rest. Whereas for the bird here, this will have a velocity v. It also has a velocity v. So whatever distance this worm covers in this direction is also covering. So under g, it comes down, the eagle says. But for him, he has no velocity. Only the worm has a velocity, and under g it falls, but falls like this. Is it all right, everybody?
Yes, sir.
Slowly, we're going to write the equations
Yes,
of
sir.
motion for those things, children. I hope everybody followed. Similar is the case with a bomber plane, for example. You know very well, there's a target which is stationary here. For example, some building which some enemies wanted to target because there are some nuclear installations there. This is at rest. Now, a fighter comes in a plane and wants to drop a bomb on it. So he should somewhat become a little horizontal like this to be more precise. Right? And he should release the bomb somewhere here only, not when he comes here. Because he should become a little horizontal, and the fighter plane has a velocity here. If it drops a bomb from below the belly of the plane, this will have a velocity like this. By the time the plane comes here, the bomb will hit the target. So the person, the fighter feels that he is dropping it straight, but we from the ground say it's following a parabolic path. Isn't it so?
Yes,
Hello?
sir. Yes, sir.
Supposing when the person inside the plane leaves the bomb here, it will fall there, not on the target. But the fighter person inside says he's just dropping it straight only, whereas we say that no, he has dropped it somewhat before he went to the target, right? And we say the bomb had a velocity v, under gravity it went and hit the target like this. Do you understand my point?
Yes,
So
sir.
when I introduce the idea of reference frame, how will I say? In a reference frame fixed to the ground, the bomb is following a parabolic path. In a reference frame fixed the plane, it is following a straight line path. In a reference frame fixed to the bird, it is following straight line like this. In a reference frame fixed to the ground, it is following a parabolic path. All right.
Yes, sir.
Yes, sir.
Or even the regular thing. Say you are moving in a train and there are windows like this. You are sitting there. Okay. You dropped one stone through the window. Somebody is standing here and you are dropping the stone. How will you see it? Let me say this is still moving with a constant velocity. I did not discuss the acceleration cases yet. Now tell me, how does it occur? How does it appear to person inside it? That is to the fellow who dropped it and the person standing on the ground. Similar ideas, right? What do you say? For the person inside, it will fall straight, but for him, it falls like this. Isn't it so?
Yes, sir.
So now there is no objection for you to talk about a reference frame. Do you? Why don't you say anything? So before we say a body is behaving in a particular way, that means a body has a particular velocity, a body has a particular acceleration, a body is following a particular path. You should always mention in which reference frame it is happening. Instead of saying with respect to what reference frame, I use the word in the reference frame. Hello, children, can I continue?
Yeah.
Right.
Yes,
Now, in that
sir.
case, just tell me, what is a reference frame now? Or where is it fixed? People misunderstand the reference frame. First of all, remember, we cannot fix a reference frame in space like that. We cannot imagine, suppose there's a reference frame like that, you cannot say. You should have some rigid body.
Sir, is it point of view?
Tell me.
Reference frame, is it point of view? Like,
yeah, it
seeing
is.
it from
It's a viewpoint,
many
definitely.
directions.
But viewpoint is not physics, right? You need to really put it in more mathematical way and more physical way. Viewpoint is all right. Viewpoint means what? Where is it fixed? That's important, isn't it? Huh? So there will be a rigid body on which you stand and watch the motion of another body. So first of all, there should be a, say, just now we told, no, I am standing in the ground, I am saying, or somebody is standing in the bus, somebody is saying. So the bus and the ground are the rigid bodies to which you can think of a coordinate system. You can think of one coordinate system fixed. Do you follow? And from here, you watch the motion of the other body. You watch another body and discuss its fate as to what is happening to it by applying the laws of physics. Okay, so a reference frame equals what? A rigid body plus a coordinate system fixed to it, and probably some measuring instruments, clocks and rods. All this will constitute what you call a reference frame, not just a coordinate system also. And for you to understand this reference frame idea properly, you think that this rigid body is extending up to infinity, this side, that side, this side, so that Because practically speaking, you need to fix the reference frame to some body only, isn't it? That body will have a definite dimensions. So when you look beyond the body on which you're standing, once again, with respect to something else, it may be moving. I don't know whether you understood my point. When you sit inside a bus, you won't be aware of the bus's motion if the bus is gliding smoothly on the road and the curtains are drawn and inside you sit. Then for you, the body is moving only in the bus's reference frame. That means you see this side, that side, everywhere you see the bus. You don't see the surroundings. The moment you see the surroundings, say some trees are there here, this side on the road, right? If you see through the window, you know the motion of the bus by looking at the trees. Do you follow my point? Hello?
Yes, sir.
Yes, sir.
When you
Yes, sir.
see towards the trees will be moving. So you think, "Arey, my bus is moving." You'll apply your common sense. So to get a real feel of the rigid body, you need to think that the rigid body is just going up to upward up to skies, and this side up to some thousands of kilometers, that side thousands of kilometers. In that, the body is there, and that motion of the body is I'm studying, you should think. I told you some time ago, when there's a river moving like that, the velocity of a swimmer in the river, there's a swimmer here. With respect to the river means, I told you, somebody is standing on a float. What did I say this is? A float or a rafter in a wooden piece. But remember, wooden piece, if you think, when you look at this side, you'll also all the time see that water moving, no? So you don't feel that you are at rest, which means you need to think that the wooden piece is extending all over like that, and on that water is moving, you should think. Then you get the real feeling of the reference frame. Reference frame axes are there, right? So you can think, like for example, if I choose my x-axis, z-axis, y-axis like this, I should think this is going up somewhere, this is going up somewhere, this is here. Of course, no issue. You can stand in the viewpoint is the origin of the reference frame coordinate system, and this coordinate system is fixed to whom? Some real body, and there you study the motion of body. This is the body to be studied. That's the body to whom you apply physics and try to understand it, and you are the observer. And this reference frame is another rigid body which supposedly having infinite dimensions, and you study, and you're not aware of motion of this rigid body which is moving maybe with respect to something else. That is the whole idea of reference frame. You may ask, how I'm not following this. What is the use of this for me? Remember, people use the words actual motion, actual velocity, like that people keep using. In their minds, they think that they are at rest and studying the motion of another body. Do you follow my point? Hello, that's a real thing people say. So even when you're watching from a moving body, you can still get that feeling of rest if you think this moving body is extending up to infinite dimensions, so that you feel that you are at rest with respect to that body which is moving, and then do the problems like we did from the ground in general. Do you really follow it? Hello? Tell me now.
Yes, sir.
This is a real idea for reference frame. I'm actually making it easy for you to solve problems in a proper way. In vector difference, I was telling you that to reverse the velocity and add. That only I'm coming back again in a slightly different way. So what is the terminology we use? A body is in motion in a particular reference frame, or a body is at rest in a particular reference frame. So reference frame is immediately should think, okay, I'm standing on another body and I'm fixing a coordinate system, and at the origin of the coordinate system I'm standing, and I'm working out physics problems to a body. Remember, this is not the one to be studied. He is the observer. It is you who is writing AC equals ut plus half AT square for this, right? But when you do that, you think the body on which you're standing is at rest, and in that rest reference frame you're watching this. You'll think you are a part of this bus, for example. Okay, so you're not, you know that the bus is not moving. So that's exactly what we think. That's what we in our day-to-day experience. All the time we think we are at rest, though we are standing on the earth and earth is moving with respect to something else. We think we are at rest, and certain things are happening in front of me, and that is the actual thing you think. Many times teachers tend to tell that it's only relative, it's not actual, nothing like that. So to get this feeling of rest with respect to the body on which you're standing, you can think of that edges of the body to be unknown to you, so that you look this side, that side, this side, and you think that thing is at rest. Do you follow my point? I'll tell you some nice example. You are aware of warships, right? Huh? On which planes land and take off.
Yes, sir.
So I don't remember exactly, but they'll be very, very wide. Do you follow? Maybe some,
Yeah, sir.
how many planes land on that, I'm not sure. I forgot. Okay. So that kind of a ship is already moving. Say you are sleeping somewhere, and suddenly in that sleep only somebody shifted you from outside to that ship's deck, for example. It is very, you cannot see that edge of the ship and this edge of the ship. Do you know whether you are in motion or not? You don't know. Unless the ship decelerates or accelerates, you will never know that you are in motion or not. And you drop a stone there. If you throw a stone there, it simply comes and hits your hand. And doing any experiment on that kind of a ship, which is going with a constant speed and which has got some, what you call 1 kilometer this side, 1 kilometer that side, for example, and you cannot see waters there or trees or anything there, you cannot tell whether you are in motion or not, unless suddenly there's a jerk happening, and when you throw a stone, it either falls behind you or in front of you. I'm talking a very, very important statement for physics. What is it? By doing any kind of experiment, you cannot distinguish whether the body on which you are sitting is moving or not, if it is moving with a constant velocity with respect to something outside. Do you understand this? Hello?
Yes, sir. Yes, sir.
There's no way. Whatever experiment you do, you will never know whether you are moving with a constant, whether you are moving or not moving, only you won't be knowing. And we want that situation of not moving with respect to the body on which you are standing. For that, I am saying a reference frame, or what you call, envelops the body completely, the body you are studying. Okay? Hello?
Yes,
so
sir.
your problem solving becomes very, very easy. I might even directly tell you how it becomes easy for a particular problem. Of course, you should be aware of certain equations. Like, say you're standing here, one stone is thrown up. After some time, this was going up and up like that. After some time, this is A, it is still going up maybe. You throw another body B like that. So when I'm saying this, in my mind, I'm having both the stones being observed from here, right? Huh? So I have G for this, I have G for this. But say, if I watch from here means you should think this, you should know that this is not moving. How will it happen? You think this is like this big, like this, and then watch this. Do you follow my point? Hello. Otherwise, you will be, when you look like this, you know even you are moving, no? So in that case, the acceleration of this will be 0, not G. So for you, this moves with a 0 acceleration, whereas for you here, for somebody here, both are moving with a constant G. So whatever I'm trying to say is this: even though you practically think of bodies, small bodies also to be a reference frames, they're not small bodies to the extent that you should not get a feeling that your body is moving. The body on which you're standing is moving with respect to somebody else. So for that reason, you can think you cannot see the edges of the body. This side, if you see the edges, you see the surroundings, and you know that you are in motion. We want you to get a feeling of rest with respect to the body on which you are standing and observing another body. So the body on which you stand, which is the reference frame, is going to be extending up to infinity, so that you feel that you are on the earth and not moving at all, so that you can apply equations happily, like you applied for a body moving with respect to the ground. Tell me, Vignesh Ramaswamy, do you understand? Hello? Did you catch my English first of all when I was speaking fast?
Yes, sir.
Right. Amar?
Yes, sir.
తెలుగులో చెప్పు, ఏం మాట్లాడినాను ఇప్పటిదాకా? రెఫరెన్స్ ఫ్రేమ్ అంటే ఏముండాలి మనకి? ఒక రిజిడ్ బాడీ ఉండాలన్న. రిజిడ్ బాడీ అంటే ఏంటి? ఆ బాడీ మధ్యన బాడీ పాయింట్స్ మధ్య డిస్టెన్స్ చేంజ్ అవ్వదు అన్నట్టు, హార్డ్ బాడీ. రెఫరెన్స్ ఫ్రేమ్ అంటే ఏదో ఉత్తిగానే ఒక కోఆర్డినేట్ సిస్టమ్ ఎయిర్లో ఇమాజిన్ చేసుకొని మాట్లాడద్దు మనం. అర్థమైందా? రెండు ఉంటాయి ఇక్కడ. రెఫరెన్స్ ఫ్రేమ్ ఫిక్స్ చేసిన బాడీ ఉంటుంది, దానికి మనం ఫిజిక్స్ లాస్ అప్లై చేయట్లేదు. దేనికి అప్లై చేస్తున్నాం మనం? ఇంకొక బాడీ, ఇంకొక ఏ బాడీ మోషన్ అయితే స్టడీ చేస్తున్నామో దానికి మనం ఈక్వేషన్స్ అప్లై చేయాలి బేసిక్ గా. సో మన నిలబడ్డ బాడీ ఏమో రెఫరెన్స్ ఫ్రేమ్ ఫామ్ చేస్తుంది. ఆ బాడీకే మనం ఆ బాడీ మీదనే ఒక కోఆర్డినేట్ సిస్టమ్ ఫిక్స్ చేస్తాం, ఎక్స్ వై జెడ్ అని ఫిక్స్ చేసి ఇంకో బాడీని ఆ రెఫరెన్స్ ఫ్రేమ్ లో అబ్జర్వ్ చేస్తాం. ఆ రెఫరెన్స్ ఫ్రేమ్ అంటే అది ఏం చేస్తుంది? ఆ ఎక్స్ వై కోఆర్డినేట్ సిస్టమ్స్ ఒక స్పేస్ ను ఎన్వలప్ చేస్తాయి. ఆ స్పేస్ లో దట్ బాడీ ఈస్ మోషన్ విల్ స్టడీ. So this whole thing is called reference frame. So it's a very, very practical thing, not just some kind of a, vague idea to do problems. And whenever you are in standing on such a rigid body, the rigid body is not going to be moving with respect to you, because you are a part of that body, right? You are a part of that body. But in this whole coordinate system fixed to this body, in that three-dimensional space, you are watching another body whose motion you are going to study, and on whom you are going to apply equations of motion and solve problems as far as our 11th and 12th class level is concerned. Hello? Can I continue? Can I believe that you understood something? No, it becomes very interesting actually once you catch this idea. In the beginning, actually, you can keep switching the reference frames and keep doing problems. So you should never be scared, or you should never be worried, this reference frame, I don't understand it. Okay? Hello?
Yes, sir. Yes, sir.
We'll test it, actually speaking. It's not just a talk here. In a given problem, sometimes switching reference frames will make it very, very quick and elegant. Okay? Now, I did not write much about the reference frame. I just put some equation-like thing. What is that equation-like thing we put here? I told you a reference frame is equal to what? A rigid body plus coordinate system fixed to it plus some measuring instruments. Come on, to know the to measure the time, shouldn't you have one watch here? And to measure length, shouldn't have a measuring rod like that? So reference frame is very, very physical. That's what I would try to I'm trying to tell you people. Of course, we don't have a measuring rod and instrument here. We simply apply the equations because people have done it already and had given us equations to work with. Hello?
Yes, sir. Yes, sir.
So I can believe that you understood something, if not everything.
Yes, sir.
Right. So I'll continue. Inertial frame of reference. Yeah, this is what we require to know very clearly. Inertial frame of reference. There are many ways of describing this inertial frame. I don't call it a definition because in physics, we reserve the word definition to mathematical definitions. Define force means I won't say push or pull. I'll say force equals mass into acceleration. Okay. So that kind of definitions are very, very accurate and very important. Mathematical expressions are definitions for us. So rest all is meaning or qualitative statements we make. So inertial frame of reference. There are many ways of describing this inertial frame of reference. Could you tell me one of it if you know it? First of all, let me tell you, there are 3 laws of Newton. Though this is not dynamics yet, I cannot escape from this talk of reference frame. Therefore, we need to know a little about the Newton's laws. 1, 2, 3. What is the first law? Every body continues to be in the state of rest or uniform motion unless and until a force acts on it. Second, F equals ma, or the rate of change of momentum is directly proportional to the applied force, and the change in momentum happens in the direction of the force applied. 3, for every action, there's an equal and opposite reaction. The second law is the most general one. We can get the first and 3 from the second law. F equals ma. If A equals 0, if F equals 0, net force is 0, A equals 0. If A is 0, the body may be at rest or may be moving in a straight line with a constant speed. Okay, these are the Newton's laws. You heard them from your 6th, 7th, 8th, 9th, whichever class. Is it okay, Vishnuvardhan?
Yes, sir.
What is the first law?
Law of inertia.
Huh?
Law of inertia. Yes.
Law of inertia. Can you elaborate that law of inertia?
Yes, sir. A body remains in the moment until and unless.
No. Speak properly. Otherwise, speak in Telugu. I have no problem.
Yes, sir. A body remains in the moment until and unless an external
A
force
body
acts
remains
on
in
it.
the moment. What do you mean by body remains in the moment?
Right.
That's not a proper, way. Body remains in the moment. Where did you pick this up?
Sir, can I try?
No. Let me talk to this fellow for a while. What do you mean by body remains in the moment? You are making. You are making some nice wording for that. Like some people say, I don't think about future. I don't want to think about past. I live in the moment. People say. I'm a cool person. I live in the moment. That's what you are trying to tell. Hello. Vishnuvardhan, where did you pick that language from? Okay, Vignesh, tell me.
So, an object remains in a state of rest until a force acts on it, sir.
Or a body goes in a straight line with a constant speed. That's called?
Constant speed, yes, sir.
Constant speed and straight line, both magnitude and direction. That's called constant velocity. In single word, it's called constant
velocity, yes.
Or uniform motion. Many words are used. So body at rest will remain at rest. A body moving in a straight line with a constant speed will continue to do so unless a net unbalanced force acts on it. Isn't it? That's called law of inertia. The body's nature, the body's property, inherent property, due to which it wants to stay either in a state of rest or in a state of motion is what you call inertia. It's only a property. But what decides the inertia is mass. Try to understand. Mass is the quantity which characterizes the inertia of a body. Inertia is not a physical quantity. Inertia is only a physical property for the body. We say, due to which it would like to stay as it is. That's called law of inertia. Right?
Yes.
And the second law is what?
So should I tell it? Fine. The force acting on an object is equal to
the net
its mass times
better make
acceleration.
it net force. Huh?
Okay, the net force acting on an object is equal to the product of its mass and its acceleration.
Yeah, that's enough. But only thing is we should know the meaning of it, the conceptual meaning of it. We should follow. So if there's a net in the first case, we said if the net force is 0, the body remains at rest or moves with a constant velocity.
Constant velocity, yes.
The second statement is also the same thing. If E equals ma, if F net is 0, A is 0. Acceleration is 0 means what? It should be either at rest or should be moving with a constant velocity. So in a way, the first and second law are one and same. Now, when you define inertial frame, there are many ways of saying it. One, a reference frame in which Newton's first law is obeyed, people say. Newton's first law is valid. This is the regular sentence you see in books. But since I told you whether it's first law, second law, it's not a big deal. So you can say a reference frame in which Newton's laws are valid. Actually, this statement I don't like. But since you keep looking at this statement in many textbooks, I'm giving it. Because what do you mean by Newton's first law being valid, Newton's second law is being valid in a particular reference frame is a little, confusing. But what it means, I'll tell you now. Huh? Listen, I'll give an example. Though I told reference frame has to be fixed to a body, I'll just generally show the coordinate systems there. We can always say that this coordinate system is in a car, on a ground, something like that. You can all the time say. Now, I have a person A standing on the ground. So this is, I'm not using any physics here. What am I saying? A is standing on the ground. This is some kind of a situation I watch. Now, this person A is being watched by few physics students. Okay. They are watching this A in various reference frames is the terminology we need to use. There is one. Okay, just let me see. I'll draw more figures anyway later. Just now, this fellow A is being watched by another fellow on the ground only. This fellow is B. Huh? Hello. So to the ground only, I fix one X axis like this, Y axis like this, Z axis into the space like that. So for B, A is at rest. Okay. But now B would like to understand why A is at rest. He knows Newton's laws. Okay. So he says on A, there's a weight acting like this, and there's a one N acting from the surface. That's a contact force. Huh? And B says, since the net force is 0, do you follow? Huh? A is at rest, he says. Because Newton's law told him that if the net force is 0, the body's acceleration is 0. That means the person may be at rest or person may be moving with a constant velocity. But for B, A is at rest here. So B is interpreting Newton's laws correctly. That's what you mean by saying that a reference frame in which Newton's laws are valid. And if I give the name S frame to it, we'll say S frame is inertial. We'll talk about this slightly different way also, but try to understand what I am talking presently right now. Vignesh, do you follow what I spoke?
Yes, sir.
When you say a reference frame in which Newton's first law is valid or second law is valid or first and second laws are valid, whatever, what you're trying to tell is this. I watch this A and I say he's at rest. But Newton's laws also should tell me that he should be at rest.
Yes, sir.
So if you ask somebody, non-physics fellow, why this A is at rest, he will say he doesn't want to move, that's why he's at rest, we'll say. Isn't it? That's not the kind of explanation we want to know. We would like to apply Newton's laws and explain the experimental result from theory. What is the theory here? If F equals ma and if F is 0, A should be 0. A is 0 means there are two possibilities. One is the body can be at rest. The body can be moving in a straight line with a constant speed. So here B says he is standing there at rest because the net force on him is 0. Do you follow? So
Yes, sir.
for him, for B, Newton's laws are valid. So the reference frame in which he is watching from is inertial frame. So Hita, do you understand this?
Yes, sir.
Amar? Amarnath?
Yes, sir.
Really? Huh?
Yes, sir.
I'll continue to talk about the same thing. I go to the next page. Now the same person, A, who is, we said, standing on the ground, is observed by a person moving in a car. Say this car is going like that with 10 meters per second. Constant. So he'll fix a reference frame to the car like this and study this person A. Now Amar, tell me what is happening to A. Hello.
Yes, sir.
What is happening to A?
Sir, with respected to B, the A is moving backward, sir.
With, once again, 10 meters per second, constant.
Yes,
Even
sir.
now, Newton's laws are valid for this person C. Why? He also says n minus mg equals 0. That means F net equals 0, which means A equals 0. So A is going with a constant speed, which means S dash frame, that is fixed to car. I told you reference frames have to be fixed to some rigid bodies, is also an inertial frame. Come on. Will people agree for that? Hello?
Yes, sir.
Really? I want people to respond quickly.
Yes, sir.
So slowly you're getting an idea. But let me see, I don't want to confuse you by talking about the same thing in different ways right now. Just stick to one line of thought at one time. Okay. So can I continue?
Yes, sir.
Yes, sir.
Right. Now the same person A, who is allegedly standing on the ground, like we told previously, is being watched by a person D inside a car, which is accelerating like this with 2 meters per second square. Tell me. For him, how does A look like? So once again, he will think of putting a reference frame to the accelerating car. Okay. Now, do you understand that I told you that the reference frame means what? A rigid body, a coordinate system, a person at the origin with certain measuring rods, for example, some watches, all that. Now, for D, let me say this is S double dash frame, double prime. For D, tell me children, A is accelerating this way with 2 meters per second square.
2 meters per second square.
Isn't it? Now, can you tell me whether D can explain this acceleration from Newton's laws? Vasist?
Yes, sir. Sure. So you're going to say that a force is acting on A.
No. He also knows that there are only two forces. What? mg and n.
Okay.
See, forces are real. Because it's going with 2 meters per second, don't say some force is acting on it. D is a physics student, I told you. He knows forces develop out of interaction. So N is developing because of touch, the real force. mg is developing because of the Earth's gravitation. So he knows very well that there's no other force than N and mg, right?
Okay, yes, sir. Yeah.
Right. So even he says N minus mg equals 0. But poor fellow, he says, come on, what's happening? The net force is 0, but the body is accelerating. So my Newton's laws application is wrong. So this is what you mean by non-inertial reference frame.
Sir, so when the reference frame is at rest or is in uniform motion, it can be said to be an inertial frame. Okay.
That's what I wanted from you to infer from. I was telling you, I don't want to add immediately. Okay, that's what the statements which I did not want to tell you, and I wanted you to infer, extract from our talk. Huh? That's
Yes.
how you make things easy for you. Huh? He
Yes.
said correct statement. Huh? But now, we don't go ahead of me. That's correct. What was said was right. That means the reference frames which are at rest or which are themselves moving with constant velocity are inertial frames, and the reference frame which are accelerating are non-inertial. That's correct. 100%. Huh? So, but this thing still is to be deliberated, Vasist.
Yeah,
Is
okay.
everybody satisfied with that?
Yes, sir.
For D, A is accelerating with 2 meters per second square. But he knows N minus mg equals 0. So in spite of the net force being 0, the person is accelerating, which implies Newton's laws are invalid here in this frame. All right. So S double dash is not inertial frame of reference. There it is non-inertial frame. So that statements I can say, like Vasist was saying, what? Reference frames which are at rest are moving or moving with constant velocity are inertial frames. right? And 2, all accelerating frames are non-inertial. All right, but remember this field is wide open to talk. Huh? So Vignesh, are you okay with this?
Yes, sir.
Really?
Yes, sir.
Manasa? Are you there,
sir.
Manasa?
Yes, sir.
Sriram? Guru Charan, are you there? I don't see you nowadays. Sriram, you're not talking. Sivacharan,
Yes, sir.
have you really followed?
Yes, sir.
Hello, sir. Am I audible?
This who is talking now?
Sriram, sir.
Yeah, now you're audible, yes.
Yes.
So can I believe that you people understood it somewhat? Huh?
Yes, sir.
No.
Okay, then I'll test you by asking another question. Of course, these statements are all right, but you should be very careful in that's why I was explaining it more than giving it a direct rule-based approach to that. I was explaining how Newton's laws are invalid because this is a statement we keep seeing in the textbooks. So I'll ask you one question here. Can I change the screen?
Yes, sir.
Right. Of course, these things keep coming again and again. Don't worry, but you need to have that kind of a an understanding from the very beginning. In fact, what we do later, no, we multiply this mass of the person with this imposed acceleration. What did I say? Imposed acceleration. Do you understand the meaning of imposed? Your acceleration you are putting on the body, right? Huh? Hello.
Yes, sir.
Multiply this imposed acceleration with the mass of this body and say pseudo force is taking him away, and feel satisfied that we made Newton's laws applicable. Okay. So in a way you understood pseudo force. You were introduced to pseudo force here, if not understood. What is pseudo force? Mass of the body into acceleration of the reference frame put in the opposite direction. A real force will be not like that. Real net force will be mass of the body into its own acceleration, not somebody else's acceleration imposed on it. Ganesh.
Yes.
What is pseudo force? This comes again. Don't think I'm not going to discuss it later. See, in my lesson, future lessons keep coming here and there to explain the meaning of the current lesson, but that will be once again elaborated further later in the future lesson. So in a simple way, how do you remember a pseudo force? In a simple mathematical way, algebraic way, mass of the body into or multiplied by the acceleration of the reference frame
In the opposite.
in the opposite direction. That's called
Yes, sir.
pseudo
Pseudo
force.
force.
Hello, other children.
Yes, sir.
Are you okay with that?
Yes, sir.
Yes, sir.
Lakshya, Dhanush, Chandra, are you there? This Dhanush Chandra, where did he disappear? I call him by name, but I don't see him. Hmm? Okay, then I'll ask you a question. Tell me, there is a person running on the ground with an acceleration. Who will provide this force, the friction between the feet and him? He's going with an acceleration. Now, somebody watches him in a car which is also accelerating with A like this. So what is the reference frame? What kind of a reference frame is there with the car? You understand what I told? This person is running with an acceleration. You know what is acceleration? Like the person is here now, he'll be later here, later he'll be here, later he'll be there. This is what you mean by acceleration. What is uniform velocity? He's here now, here later, same time he's here, same time he's here, same time. This is called uniform. This is acceleration. Do you follow? Hello?
Yes, sir.
This is what you need to visualize in terms of space and time. So he's accelerating like this. Okay. So I watch him in another car, which is going like this with the same acceleration. So I'll say his acceleration is 0. Okay. Hello. How do you know? Relative acceleration, reverse it and add it.
Yes, sir.
So his acceleration is 0. There's no doubt about it. But tell
Yes,
me,
sir.
what is this reference frame called? If you answer this with proper meaning and discussion, you've understood the meaning of inertial and non-inertial frames. Why are you silent? Say something, let it go wrong. Anytime remember, when you learn sciences seriously or anything, a craft, you have to do mistakes. Only then you'll understand what is correct.
Sir, so is it non-inertial?
Yes, I was expecting you to say that because you are the person who summarized it. No, all accelerating frames are what?
Non-inertial, sir. So.
Non-inertial. Correct. Most likely it is non-inertial. What did I say? Most likely it is non-inertial.
Okay.
Can you further elaborate it? You went to that rule. All accelerating frames are non-inertial. So we said non-inertial. But yeah. Can you explain it in terms of the Newton's laws being valid and invalid? That's what I want from you. Okay?
Yes, sir. Yeah.
This is correct only. Correct only. Come on, children. Somebody else? Why everybody is silent? Huh? Hello, children. Say something. Let it be wrong, I told you, no? Come on, why are you so defensive about it? Children? Vignesh?
Yes, sir.
Sriram? People are dropping out already. Sriram? Ganesh?
Yes, sir.
You should learn something new, right?
Yes, sir.
So I've already started teaching you new things. So I should get convinced that you're actually learning new things and extra things from the new teacher.
Yes.
So look, we said the person is accelerating, which means there's a net force acting on him. The force are real, children. Some friction also, I just gave you a clue also to tell you that. So this person is accelerating means there must be a net force acting on him, isn't it? But now when you look from here, the net force is becoming zero and his acceleration is zero. So if there's net force, it will accelerate. You cannot say that he is not accelerating. Even that way, you're violating Newton's law. That's why it is non-inertial.
I'm sorry, sir. I didn't understand. Could you please repeat that?
Come on. When we said this person is running with an acceleration, it is true. There's a net force acting on him, right?
Yes, sir. Yeah.
But now you say the acceleration is zero. If the net force is there, why the acceleration will be zero?
If there's an opposing force.
No, there's no opposing force. he's accelerating, that's all. Not because you're watching, there will be opposing force developing, right?
Oh, okay.
Yes, sir.
Okay.
So once again, Newton's laws are violated. Come on.
Yes, sir.
That's why. So to avoid this kind of trouble, we simply say all accelerating frames are non-inertial. But if you understand that also, life will be good later to solve problems. I told, if you said A is accelerating, it means there's a net force acting on him. That's true. But now watching from an accelerating frame, you're saying the acceleration is zero. So if the net force is there, how can the acceleration be zero? So am I not interpreting Newton's laws wrongly?
Yes.
That's what you mean by Newton's laws being invalid in the non-inertial frame of reference or accelerating frame of reference. Okay.
Okay, sir. Yes.
More of this, of course, it is, I told you, is a very wide open kind of a discussion. People can keep talking, but since we're not discussing Newton's laws yet, probably that may not be possible with you to talk more about that. But finally, yes, the statements we made, a reference frame at rest, a reference frame moving with a constant velocity are inertial, a reference frame which is accelerating is non-inertial. Okay, and more of these reference frames will bring back in Newton's laws of motion. All right, thank you for today. Sir. I'll be closing the session.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, children.